In this question, we've been told that a particle is moving in a straight line with a constant acceleration of 5.9 meters per second. It passes a point A with a velocity of 21 meters per second and later on passes through a point B where the distance between them, the length AB, is 171 meters. We're asked to first find the velocity of the particle as it passes through B. So I'd like to just keep track of that on a visual diagram. We have a journey from A to B. The initial velocity is 21 meters per second. The acceleration, we're told, is 5.9 meters per second squared. And the displacement, the distance from A to B, is 171. So let's just collect those variables in our SUVAT table. So the displacement, 171. Initial velocity, 21. We have our unknown final velocity. The acceleration is 5.9, and we have our unknown time. In this question, we're looking for that final velocity, the velocity when the particle gets to B. The formula to use, v squared equals u squared plus 2as. Substitute the values that we have, and after some rearranging, we see that v is going to be the square root of 21 squared plus 2 times 5.9 times 171. All of this can go into your calculator, and we get a value for v of 49.6. The velocity of this particle when it passes point B is 49.6 meters per second. Next, we're asked to find the time taken to travel from A to B. So this is still the same journey segment. We're still thinking of the same journey, so I'm going to work with all the same SUVAT variables. The time taken to move from A to B is going to use S, U, A, and T. So the formula is S equals UT plus half AT squared. Looking for T, we know we're going to get a quadratic equation. Substitute your values, rearrange, and we can solve the quadratic. You can go ahead and factorize, use the quadratic formula, or complete the square. But I recommend in applied, you're making use of the equation solver on your calculator. Either way, we get two answers. T equals negative 12 or T equals 4.85. Because this is applied maths, you do need to think sensibly about whether these answers are appropriate. We're looking for the time that it takes for the particle to move from A to B. It wouldn't be sensible to have a negative time. This would be 12 seconds before we started observing the particle. So we'll go for the positive answer and eliminate that negative answer. Be careful in your exam, if you haven't shown that you're eliminating the negative, you will miss out on a mark. So just a line to go through it, or a sentence to say why it's not appropriate, and that you're following through with the 4.85. Okay, so the time it takes to travel from A to B is 4.85 seconds.